Hello, I'm Professor Hudson Zanin. I'm work with University of Campinas, and this is our program of the electrification of the transport. This is the phase one where we develop parts separated and then we integrate this in the bench top. Okay, so we're going to develop reformers to reform ethanol, and then use the hydrogen reformed in the solid oxide fuel cell, and that solid oxide fuel cell going to power batteries, and the battery is going to power a small electric vehicle or electric motor, so up to 5 kilowatts. So the phase one is basically this part here on the bench top where we use ethanol and water. A reformer. We're going to develop this reformer. I'm going to give you more detail about this. So we're going to develop a solid oxide fuel cell, then integrate this in a pack like that. So to have a more power. Only one cell give you us about zero point 0.7 volts. So we are interested on 300 volts, and then we're going to have this pack powering the battery like the models of batteries and the packs of batteries that's going to power the electric motor. Okay, of course we need extra power sometimes, and this is going to come from supercapacitor modules, and also we're going to use this power for extra charge or in the battery, or just for extra power for the electric motor, for the engine. And of course we can use this as a regenerative braking, um, to store energy, so in a few seconds. Okay, so this phase one, we're going to take up to 3 years in our group, and then we're going to move to a car. So we're going to put the cells inside the system, inside the power system, the powertrain system inside vehicles. So the reformer is nothing but a reactor, a metallic reactor with aluminum, which we impregnate sol gel, metal organic uh, solution to impregnate these metal oxides, for example, nickel with cerium oxide, and this is going to work as a total converter of ethanol. So 100% going to be converted between 250 up to 650 degrees Celsius. So the main question is that are we able to have the selective, that we're going to have more hydrogen than the other stuff. So that's the point. The hydrogen is very important. We're going to play with a different catalysts to have this hydrogen, and this hydrogen go in their interconnect. That's a metallic structure that give support to the system. So then the hydrogen going to come in the porals, and then reach the anode, which is yttrium stabilized zirconium, and the hydrogen come up, and the oxygen reduced, the oxygen ion down. The oxygen going to be reducing the manganate, lanthanum, strontium manganate, and this is going to reduce the oxygen and going to reach the hydrogen. So that's very important, because we have water and electricity formed here, and this is going to be used to power the batteries. So one cell just give us zero point 0.7 volts and a few amps or a few milliamps. So we are really interested on associated cells, which is a trick stuff, because we're talking about hydrogen, we're talking about gas. So this installation must be very good. So we're going to making this the sealing properly with lasers, and this laser is going to seal all the cell. The sealing is very important. Then we're going to develop this models using the electronic. We're going to develop the cell in a project, specific project, supercaps, battery, lithium-ion battery, and then we're going to develop the models with the electronics and all this stuff. So we are talking about here different projects where we develop the cell, for example, in this first one. The other one, we develop, let's say, supercap cells. Here we develop not just the lithium ion, but also the lithium sulfur and the models. And we start a solid oxide fuel cell. And then we go for more complex electrolytes, like a all solid state electrolyte. That's very important to have no flammable device and a high power device in other projects. So and the other project, the fourth project, we developed the whole completely solid oxide fuel cell. So we have also there's a completely cell, but also we have the interconnect integrated with a reformer. So we have a reformer in the interconnect. So this is very interesting because it's a very good for exchanging heat on the system. And in this last project, we have the reformer separated, which is easier to exchange, replace. And we're going to play with laser welding to make everything, making the ions inside and the gas inside the pack. So basically, what we are talking about that we in our group we at Unicamp we have five projects, and these five projects we integrate in the benchtop to make sure that we can have, for example, tank a gas a car that filled with with ethanol, and then the car is electric. The engine is electric. So we make sure with all this step, if it's worked properly, we use the hydrogen from the ethanol to power the system. So the main advantage is that the hydrogen from ethanol is easier to storage, easier to let's say to transport, and safer, much safer, and easy to recharge. Compare, for example, with electric conventional battery EV. So this is the charge of the system is the fulfill the tank is 10 minutes maximum or less, 5, let's say. Okay, there's a great advantage, and Brazil has a lot of ethanol here. So that's the program we're talking about, and that's our partnerships. We are very grateful for all of them.